Hey guys, so today I'm redoing a video that I had previously done about Throttle Servo Setup. And I'm redoing it. I had taken it down because I think I caused some confusion. I was getting a lot of questions. I think in part because I didn't go into describing what was going on with my geometry here, and why. I just set it up and said this is how, and it was an example and it was a good setup. And a lot of people found that very useful, but I had equal amount of people that were confused because of omitted the geometry. So I'm going to go into this a little bit more and show with a couple of diagrams what's going on here. First of all, there's a video that Scott Bauerschmidt had done on RC Tech previously, and invite you to check that out as well, because that's a good precursor to this video. So what his video, and if you want to find that, go on YouTube and search RCTEK, and you'll come up with the RC Tech video library, and one of the very beginning ones he did was throttle. So in that, what he did was found the low throttle, found the high throttle, and then figured out the middle, and then worked out from half throttle on that way to get his full and his low throttle. And that's a very good setup. If you do anything, do it that way, because he goes into depth explaining why we need a couple of things. And one of those things is on our transmitter, on our endpoints. I haven't set anything up on this, but you notice my throttle, I'm starting out at 100. I'm going to probably back that down to 75 and see where I get from there. I have to have a pretty short servo arm, honestly, especially on a DA70, to get up to 100. But we're going to see what we can do here. But it's very important for you to have those numbers when you're all said and done and you're happy with your throttle to be the same or within a couple. You never want to have like your low one way down here in the 20s or something, and then have your high one at 100. What that tells you immediately is that you have very bad geometry, and you likely have a very peaky throttle. That, or you have all your throttle right here and nothing from little about half or up. If that sounds like a case that you've had in the past, then this video is going to be for you. So before we get into the full setup, I want to explain a couple things about geometry. Undoubtedly, if you've ever researched this, you've seen this diagram. Obviously, this is a bad copy I found in a Google search just now, and it's pretty grainy, but we can make it out. So this has been around forever. So just to explain what's going on in this diagram, we've got a little over a 5/8 inch servo arm, and a little over, looks like about 7/8, little over 7/8 of an arm on the throttle. So the way they have it in here, if you look at the degrees of rotation, at about 60 degrees of rotation, so they're a little bit over, well, they're exactly half. So, because we're going up to 120 degrees in this diagram. So they're halfway, and our throttle is at 21 degrees, and we're headed to, we'll say 65 degrees. And so it's about a third of the way. So they're about a third of the way at half throttle on the servo. And so the way this is right now, and this way this is set up, they are going to be about half RPM at half servo, but only a third of the way open on the throttle. So just to make sure, we probably seen that, but not really absorbed those numbers. So let's take a look at a little bit more closer into why this is happening. So what I did is I drew a little diagram up here in AutoCAD. Let's zoom in. That'll work. So what my diagram is showing you is that I've run out two different diagrams over here based on this. So here's a servo. We've got 0.7, it's 3/4 of an inch here and 1 inch here. So this is our 0.75 inch servo and what's happening, and this is our 1 inch servo arm. So if you can see here what's happening, I've divided the circle of rotation, so this is 0.75 in a full circle, and these are 10-degree increments. I divided that up in AutoCAD, and this is the same thing with 1 inch, 10-degree increments. So if you look here, if the servo, when this arm is in this orientation, for every 10 degrees of rotation, it's having a linear motion this way of 0.031, so it's about a 32nd of an inch. But when the arm is this way, for every 10 degrees of rotation, we've got 0.094, which is 3/32 of an inch. So it's a substantial difference in linear motion difference from here to here. And then for a 1 inch arm, which 1 inch is going to be your maximum size of arm you're going to want on a servo, so I did that one as well. So same thing, out here we've got a 1/16 of an inch, and here we've got an 1/8 of an inch. So we can see that a 3/4 inch arm is going to probably be our better option, but we're getting a drastic difference. So we're going to use that. That's where we make up the difference between having the stick on your throttle at half and your servo or your throttle arm only at 1/3 open, because you can see we can make up that entire other 2/3 of throttle motion right here with having the same amount of stick motion as we did here with our first third of throttle opening. Okay, so back at our throttle and servo here. So what I'm going to do is just go through a couple of scenarios and just show you a couple of things. I've already explained that you want your endpoints in your transmitter to be the same or within a couple. We'll get to that. I just want to show you physically what's happening with a couple of things. Very key, if you didn't pick up on it, servo arm length is going to be key. I said there 1 inch is going to be kind of a maximum. You're never going to want to go over an inch. If you don't have the right servo arm, drill a hole in it or something to get you down within this range. This particular arm I'm working on is a 1 inch SWB, so the outer hole is 1 inch. It's 440, so these are about 3/32 apart. So we've got 1 inch, about 11/16, all the way down to 9/16. So we're going to play with all those holes and see and show you what the difference is. So I'm starting off, I usually make my own servo arm. So what I'll do is I'll figure out where my geometry is, and I'll figure out where my carburetor is, and I'll do a couple measurements, and I'll make an arm from threaded rod and carbon sleeve. I know a lot of people don't do that, so I'm going to start out the way you probably are going to do it. So I've got a 3.5 inch arm here, and I ran these through and threaded them previously, so they're going to be easy for me to adjust. So what I'm going to do is just get this started. Now this is on the DA70, that's low, and this is full. So, and I've just kind of thrown the arm on here the way anybody might throw it on there. So if we just do that at a 1 inch setting, I'm just going to show you the difference that we get with minor adjustments. So right there is, and none of these are going to be ideal. I'm going to get to the final one's going to be the ideal setup for you. So here we are at low, and look at how little movement this goes to get us to full throttle. We barely moved. So what that's giving you is extremely low servo resolution, and you're going to have both numbers on your transmitter extremely low. It's going to be extremely touchy. One little click of trim or something is going to give you a fairly drastic throttle change. So now let's just turn this in a little bit. I'm just going to turn it in probably 3/4 of an inch total here. Okay, now look what we did just with 3/4 of an inch. See where the arm is now? And we moved the whole arc. Okay, so now if we take and shorten this arm up, I'm going to move this back out to where we started. going to move this in to about 9/16, just over half of an inch of servo arm. Okay, now we have our idle is there, and our full is here. So we're actually, if you were going to do something, that's actually not terrible, but we definitely are going to want to see where on the stick, we want our half stick at that point to be right there. So what that's going to give us though is, remember, our degrees in between here. So what's happening on this setup right here? We're starting out, we're not very far over, so we're already moving pretty fast. Per degree, we're moving pretty fast this way. And right off the start, we're moving fast, and our engine is going to be peaky on the low. And then it's moving fast away, and it's going to be dead by about here. We will have no real RPM increase, and we have all this throttle to go yet. So that's going to be a very non-linear throttle setup. So what I'm going to do is shorten the arm up here to a 3-inch, and we'll just work our way in, because I already know, I did a couple of samples here, and I know that I want the shortest servo arm possible, and I can actually get this a pretty good geometry right in here, so that's what I'm working towards. Yeah, there we go. Okay, so there we go. I'm going to put this out at 1 inch. I've just got it started on a 3-inch arm, and there's closed, and there's open. Look familiar? We barely have any motion at all because we're out at that 1 inch. And the DA70 has a particularly short arm and a very small amount from full. So it's on a DA70, it's particularly important to have a really short arm. On a DA120, GP123, etc., we can usually get away with a 7/8 or a 1-inch arm because the range of travel is a lot more on the carburetor. So keep that in mind. So what I'm going to do is move this in. I think this one was about 11/16, and we're going to check out our range of motion. There's our idle, and there's full. So I'm going to go in one more. Now I didn't measure what this one is. We're roughly oh, that one's about 11/16. Our previous one was about 13/16 or so. So we're going to put that in there. Now we're actually getting kind of closer to what our diagram showed originally. That's actually really close to idle right there. And that's full. So you see what we have now is on our low from idle, let's see, our half throttle, or if we have 100 and 100, half is going to be about right there. And my servo arm here is about exactly a third. So we're actually very close here. Now I don't have these turned in very much, so what I'm going to end up doing is putting this arm back in and turning it in all the way to get us in there. First, I guess I should explain one thing. What am I talking about with 1/3? Obviously, I said that at 1/3 throttle is half of your RPM that your engine is going to produce. So how did I figure out where that was? I just put a servo arm in here, or a push rod. And easiest way to do it, put that in there, push it closed, and you can just put a dot. Okay, push it all the way open, and put a dot. That's our linear range of motion on this carburetor. So you measure that. That is 3/4 of an inch. So what's a third of that? 1/4 of an inch. So if we move that 1/4 of an inch right here is half RPM. I won't say half throttle. It'll be half the RPM that you're going to get out of this engine is right there. There's idle, half RPM, half RPM, full RPM. So there's 2/3, 1/3. So if that makes sense. So that's what we're getting, and we're going to use the geometry from this motion to make sure that we have this right at half stick. Okay, oops, right there. So that we want that at half stick. We want our arm to be right there. And that's going to give us a RPM increase with every movement of the stick all the way to full. Okay, so what I've done here and how I'm going to start this, I'm pretty sure that I'm going to get this to work with a 3.5 inch arm once I get it turned in more than I can by hand. And what I've gone ahead and done is just so that I can get the most resolution possible and put this all the way in, I'm actually at 9/16, so just over a half of an inch. And what I've done is I'm taking my transmitter and I've actually been starting a little bit, so I've got it at 112 and 112. I just went up a little because I know it's going to be over 100 now with that super short arm. I've got my stick at half and it's on, obviously. So got it on. What I'm going to do is, I believe I was on that cog. So what I'm going to do is turn this in until it hits my 1/3 servo mark. Okay, so I tighten that up until we're right at our 1/3, and now I'm going to see where we're at. So I've still got it at about 112. So what I'm going to do is I'm going to throttle down, and you can hear that I'm right there probably. So my idle is going to be about there. Oop.
Timer cleared.
Sorry about that. Alright, and so that's going to be about idle right there. And then full throttle, we're not quite all the way. I've still got a little bit to go. I know you probably can't see down in there, but I've got a little bit to go. So what are we going to do? Instead of going over and doing this and adding it, I'm just going to do that for fun, see where we end up. Okay, so I'm actually about there, and I do have my idle up, so that's actually, I have it up so that that's to my extents. Actually, no, I don't. So I should have right there, actually, with my idle down. So here's my numbers where I am. I thought I was pretty good. Now I'm at 87/144, and it does work pretty good. But because of that, because of being off, I'm going to have a jumpy low end of the throttle. So I'm going to half, that's half stick, and there's a second half. So this is actually moving a hair more. So what we want to do, instead of accepting those numbers, what I'm going to simply do is adjust the length of this rod. Okay, so what I went ahead and did is I shortened the length of the rod, and I put my numbers back to 112 and 112. So I just want to show you that. So remember on our last one here, we were way off. Now I shortened the rod just a little bit, and now we're going to see where we're at. So I'm going to go all the way down, and we're just about there, and go all the way up, we're just about there. So let's dial it. Actually, looks like we might want to shorten it just a hair more. Just looking at the butterfly, I know you can't see it. So I'm going to add values and see where we're at now. So we're at full throttle. We'll just go until it makes a little noise here. So there's about 127, and we're on idle down this time. Go down. So we're a lot closer, but we're still not there. So what I'm going to do is go ahead and shorten it again. Okay, so idle. max. There we go. So now we're at 123 and we're quiet, and I will check a little bit closer here, but you can hear the servo obviously. I'll go to idle. There we go. We're only 2 off. And now look at our range of motion. Try and get my transmitter in here, sorry. Alright, so range of motion. There's half, and we're half stick, and we're at 1/3 open on our carburetor. And then there's our other half stick. Just like that first diagram that we showed you. So if that happens to be a little too linear and it's a little bit too dead on the bottom, perhaps, you know, maybe through there, maybe that's a little bit too dead for you. Like if you're 3D and you like to pump the throttle, you might want to move this out a little bit. But hopefully this illustrates that you can clear up those numbers that are way off and really clear up a jumpy throttle simply by adjusting the length of this push rod. It's a big thing that you may not think about. But hopefully we've illustrated here how small, remember at the beginning here, all I was doing is making finger adjustments, and it was making big changes in the sweep of our arm here. And we really can do it just by getting the right length of rod. Okay, so I went ahead and finished that up and actually ended up very close. I put the washer, got everything on here and Loctited and tightened up. Got this on here and everything set up, and here I'm at low throttle. It's kind of a noisy servo anyway, but I'm right there, and that's actually set up just a little bit for an idle, and I have an idle up here as well. And now I'll go to full throttle. Sorry. There we go. There's full throttle. And there's half stick. You can see I'm at my 3rd half stick. So this is going to be an extremely linear throttle setup on this one. I'm not sure this would totally be for me actually, so I'm going to reset this again. I have this a little bit loose yet because I'm going to reset it a little bit. I'm going to make it just a little bit more touchy on the bottom because that's the way I prefer it. But the way I've done it here is going to give you the most linear throttle from bottom all the way to the top. So like I said, every stick movement is going to give you an increase. And then you can play with it however you like. So as I said, I'm adjusting this more for the way I like it. So I moved the servo arm, the ball length on the arm is out at 13/16. So I've set that, adjusted the length of my push rod so that now I'm at, you can see my stick movement is at idle and then half throttle and then full throttle, and my half throttle is still at the 1/3 open because I've adjusted the length of my push rod until I got the correct numbers as we illustrated. And then my final numbers are extremely close. And so what I've accomplished here is giving me still a linear throttle, still half stick is half RPM, and I'm just a slightly more touchy throttle the way I like it. So there you go. You can see how you can play with that and fine tune it for yourself and how to get there. And most of all, I hope I explained the thing where I'm getting half stick at 1/3 throttle and how I'm getting the other 2/3 with the rest of it. So good luck with your setup. Hopefully it works good for you.